Hello again, Year 11. Today we are going to start looking at curved graphs and we are going to be looking at how we can find the average rate of change between 2 points on a curve. So today's lesson will be a little bit more difficult if you don't have access to a printer because I have produced some graphs for you to use. So what I would say is if you do not have a printer, you focus on making high quality notes, drawing out some of these graphs, and if that takes you the whole hour and you don't manage to get onto any of the questions, then maybe just look through my answers and think about whether you would have been able to do those questions. So as I've said, if a function is not linear, in other words, it's a curve, the gradient at any point on that curve is constantly changing. So as you can imagine at B, where the curve is steep, the gradient is going to be much larger than at A, where the gradient is shallow. So what we're going to be doing today is looking at one way we can approximate the gradient on a curve. And that's by looking at something called the average rate of change between 2 points. And the way that we do that is just assume that the function between A and B isn't a curve and it's just a linear relationship. So we join them up with a line that looks a lot like a chord and we just find the gradient of that line. And we can do that in exactly the same way that we were finding gradients last lesson. So we can either draw in a triangle or, if you prefer, express the coordinates and use the formula. I will probably, since we have graphs today, be using the method of drawing in triangles. So example 1, it says calculate the gradient of the chord between 4 seconds and 8 seconds. And we have got a velocity time graph today with a curved function. So how am I going to do this? Well, I'm going to need to find these points on the graph. 4 seconds is there, and 8 seconds is there. And you're obviously going to join this in with a ruler to make sure that it's neat and tidy, okay? But that is the line that we're going to find the gradient of. So using our knowledge from last lesson, this should be super straightforward. I'm going to find the difference in the y. Well, that is going from 1 to 4.5. So that difference is 3.5. And the change in the x, because it's from 4 to 8 seconds, we know that that is 4. So if I'm going to calculate the gradient, I need to do, I'll write gradient, the change in the y, 3.5 divided by 4. And I think that's 0.875, but probably just worth checking that with a calculator. It's very early this morning and my brain's probably not quite working, but no, it's fine. It's 0.875. Now, quite often with questions like this, particularly with a graph that's measuring something, we might be able to put some units in here because we have done the rate of change of velocity in meters per second per time per second. So this is meters per second, or, as some of you might know from science, meters per second squared. So my next question is, what is this gradient representing? What is meters per second per second? What is the gradient showing you in this graph? Well, it's the rate of change of velocity, and the rate of change of velocity is called acceleration. So this is acceleration. and we can see it is accelerating at 0.875 meters per second squared. In my second example, we have I believe, a aircraft flight, and we have the y-axis that is got the altitude, so how high up the plane is in feet, and along the horizontal we have got time, but this time in minutes. And our question says, calculate the gradient of the chord between 20 minutes and 45 minutes, and then there's some extra questions at the end. So let's find 20 minutes. It is that point there. Let's find 45 minutes. It is that point there. And that is the gradient that we're going to find. So I'm going to draw my chord in. Again, please use a ruler. And that is the gradient that we need to find. I'm already starting to think that this line is sloping the other way. So we're going to end up with a negative gradient. So please remember that. So let's look at the change in the altitude. 36,000 down to 28,000 is a reduction of 8,000, and that is within a 25-minute time frame. So when I work out my rate of change, it is going to be 8,000 divided by 25, and 8,000 divided by 25 is 320. We need to remember this is a negative gradient, so I'm going to put a negative symbol in. And what would be my units this time? Well, we have done feet per minute. So I could maybe abbreviate that FT per minute. So that is giving you an idea that the plane is descending 320 feet every minute. It then says go on to calculate the gradient of the chord for the next 45 minutes. So that implies we're starting at 45 and we are going to 90. Okay, there's absolutely no way that I'm going to be able to draw this in straight. It'll do. And let's drop my perpendicular. Let's pop in my horizontal. Well, we definitely know that that's 45 minutes because we were told for the next 45 minutes. And let's look at the change in altitude. So 28,000 down to 8,000 is 20,000. So for our gradient, we're going to need to do 20,000 divided by 45. I'm not anticipating this to be a nice number, so I'll use my calculator. 444.4 recurring. Still negative, because the line is a negative gradient, and that is feet per minute. So it now says compare your answers. So what is happening in the second 45 minutes compared to the initial 20 to 45? So the rate of change has increased. So the plane is descending more rapidly. Now, I know there's going to be a little bit of an argument that negative 320 and negative 444 is further down a number line. So you might argue that that number is decreased. But since I've talked about descending in my answer, I've just clarified what I mean, that it is descending more quickly. So there is a sheet with 6 questions for you to try. Um, Again, you're really going to need to be able to print this out. You could do the questions by just reading the graphs and reading the numbers off. That would work, but obviously it's a little bit more difficult to be accurate. So remember to check your answers using my answers at the end. Do not hesitate to get in touch via the Ask the Teacher channel.